Okay, so let's start off real simple. Okay, so that very first one, the one that only has single bonds, what does that belong to? Which family of hydrocarbons does that belong to? Okay, alkanes. What about the double bond? Al what? How do you spell it?
Alkene.
Alkene. Okay, what about the triple bond? This one up here. Alkyne. With a Y. Okay, pretty simple so far? Okay, good. See if we can make it a little bit harder. Can't see it on my side. Okay. So there's a couple of ways of drawing organic molecules. One of the ways of drawing organic molecules was the way that we just did it. Now, if you have 15 carbons all in a single chain, and you have to draw them all out and draw all the hydrogens out, that's going to take a while, right? So chemists develop another way of doing it. It's called the skeletal structure. With the skeletal structure, actually, let me go back to the page before. This guy has 1, 2, 3 carbons, right? You guys see that 3 carbons? So the way we would draw this, just using the skeletal structure, is each point represents a carbon. 1, 2, 3. Since they're all single bonds, you know how many hydrogens you're going to have. Here, around this carbon, you'll have 3 hydrogens. Around this carbon, since it's a center carbon, you're going to have 2 hydrogens, because we know that carbon has 4 attachments, right? And they're all single bonds. Then you'll have 3 things that'll be attaching here, just like we see right here. We'll have 2 hydrogens attaching here, like we see right here. And we'll have 3 hydrogens attaching here at this end, okay? And we don't have to draw all of the hydrogens out. All we have to use is each of the individual points. This is 1 carbon, that's 2 carbon, that's 3 carbon, okay? So this symbol here this little mountain, represents the same thing that's right here. Okay, you guys understand that? Yes, ma'am. Yes, you can. Okay, in the case of a double bond, we go through the same process. The only thing that we do differently is we draw a double bond instead of a single bond. Oops. Okay. And in the case of a triple bonds are a little bit different. Because they're going to be linear, right? So with that next molecule. So you'll have to draw them being linear. So that's 1, this is 2, that's 3. Okay, so 3 carbons. Do you guys understand that? Pretty simple, saves you a lot of time. Okay, so let's say we had 15 carbons. So we'll say C15 ends 6. So C16H 26, 32. Okay. Now you guys draw it out with just the carbons and all of the hydrogens. And remember, carbon can only have 4 attachments, and you want all of the carbons to be attached to each other. So I'm going to draw it out for me, right? Over there. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, I'm done. Right? So do you see the difference? You see how long it will take to sit there and draw out that hydrocarbon when you're working with tons and tons of carbon by putting the H's and the, okay? So this guy is called the skeletal structure. It gives us exactly the same information that we got from our other structure, right? Without having to write in that C and all of those H's. Okay? So we have our traditional, like Lewis dot structure, and then we have what we call our skeletal structure. Skeletal, like skeleton, skeletal. Okay, this is our skeletal structure. Now, when we're naming hydrocarbons, the naming of hydrocarbons are going to be a little different than how we name inorganic molecules. The name is always going to be based upon the longest carbon chain that you have in the molecule. That's the first thing. The way that we start our naming, there are these prefixes. I'm going to put them up here. I'm actually going to type them because my handwriting is like a second grader's, if that. So met, F, prop, bute, pent, X, actually should be meth, prop, buta, penta, hexa, hepta, octa. Oops. Nona. Deca. Un deca. Do deca. Trideca. Okay, so met means one, eth means two, prop means propa means three, but means four, pent 5, hexa 6, hepta 7, octa 8, nona is 9, deca is 10, undeca is 11, dodeca is 12, and trideca is 13. So if we have this structure here, one, two, three, four, five, six, seven, 8, 9. So this guy has 9 carbons. So we would start it out as known, N-O-N. And then since they're all single bonds, we'd put A-N-E. So no name. So if I have this guy, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What would that be called? Undecane. Un. Each point counts as a carbon. That's 1 carbon, that's 2 carbon, that's 3 carbon, that's 4 carbon, that's 5 carbon, that's 6 carbon, that's 7 carbon, that's 8 carbon, that's 9 carbon, that's 10 carbon, that's 11 carbon. Okay, simple. Okay, so if I have a double bond, this guy has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 carbons. And it has a double bond. So what do you guys think I would name it? What is do I multiply it times 2? No, I don't multiply it times 2. So I have a double bond in it. So how do you think the name is going to change? So when I went and I called the family that were all single bonds, those were called alkanes. Then they were called alkenes. And then they were called alkynes when there's a triple bond. So double bond was alkene, K-E-N, let's say K, let's say A-L-K-E-N-E, right? So this guy has how many how many carbons? How many? It was 12, right? So we have 12 carbons. So a 12 carbon thing is called do. That's right. It's going to be E-N-E at the end. Dodecene. because there's a double bond there, it makes it dodecene. You're letting me know that there's a double bond. Now, the other thing that we have to do, we have to tell where the double bond is at, because there could be multiple double bonds, or there could be one double bond, right? Or there could be, 4 double bonds in this case, right? So we have to say where the double bond is at. The way that we determine where that double bond is at is by where the carbons are. So we would number our carbons. You want to number it to the nearest functional group. So in this case, the double bond is our functional group. So I have 2 ways of numbering this carbon. I can number it this way: 1, 2, 3, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or I can number it going the other direction. Where we start off with 1 on the other side, like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Now, the way I decide which one I'm going to use is where is the nearest functional group. So is it the green numbers or is it the brown numbers? It's the brown, because this is our double bond. Okay. Now, when it's a double bond, you want to start it at the carbon that it starts at. This is the first carbon. This is the second carbon. This is the third carbon. Okay. So then I would name this guy 3-dodecene. Okay.
Okay, so quick question, Dr. Henry.
Yep.
So, okay, when it comes to numbering, so this is just something that we would have to remember, that once you're counting, you're gonna start how you would usually start from 1 through 10, from left to right. But when you're going the opposite direction, from right to left, that's what would be how I'm trying to say it. Like, that's how we'll be able to tell, right?
Yeah. So it would be the one that gives you the lowest number possible. Because if I went the other way, right, we would be starting at 9.
9,
3
yeah.
more than 9. So if I went with the green numbers, we would start at 9. It would be 9 dodecane. That would be incorrect because it's not the lowest for the functional group, or the functional group with the most priority. And we'll be talking about that as you guys are introduced to other functional groups.
Okay.
Okay.
Yeah,
So
makes sense.
So you want to give you a test run here. Okay. So okay. Here's your first one. That's your second one. And then we'll talk about your third one. Okay, so you guys work it out. Okay, so Bailey. Bailey, you're going to do the first one, the top one for me. It has a double bond. So, wait. How many carbons do we have? We have 9 carbons. Okay, let's count them. So if we go this way, that's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8, that's 9. So we have 9 carbons. So are we going to do numbering this way, or are we going to start at the other end? We're going to start at the other end. So I should have started at the other end. Darn it. Okay, so we're starting at the other end. So what is going to be the name, Bailey? Help me out here. You said it's going to be, what is going to be that prefix that we use? Nona. Okay, so we're going to use Nona for 9. So it's known, and then E-N-E, okay? And then the number that I'm going to tell, what number am I going to put there for the double bond? It is 1, that is correct. So it'll be 1, nonene. Okay, let's see. Let's go with Azucena. She's in Kalinga, not you, the one in Kalinga. Azucena, are you there?
Yes.
Okay, so what is the first thing that we should do?
You count the, I don't know what they're called, but like the little pointy peaks.
Okay, so
And
we'll
you
just say
start off-
carbons. We'll count the carbons. So we're gonna
Yeah.
count the carbons.
You start off from the right side, don't you? Or is that only if it's a double bond?
That's only when you have a functional group. So here it doesn't matter. It could go either way.
So how do you tell the difference between a functional?
A functional group, a double
Yeah.
bond is a functional group. It's like a
Okay.
different structure than just, okay, so a functional group would be something different than just the normal points that you have, right? So if you have a double bond, that's a functional group.
Okay, got it.
Okay, so we'll count 1, 2, 3, 4, 5, 6, 7. Okay, so what am I going to call this guy?
Hepta,
And then what am I going to put at the end of it?
a suffix?
What is the suffix am I going to use?
I'm not too sure.
So since it's all single bonds, am I going to use E-N-E? Am I going to use A-N-E? Or am I going to use Y-N-E? A-N-E.
Sorry. Can you repeat that?
I said since it's a single bond, we're going to be using the A-N-E. If it was a
Okay.
double bond, we would be using an E-N-E. If it was a triple bond, we would be using a Y-N-E.
Okay.
Okay? Okay, so this third one, although it doesn't look like it, you have 2 double bonds. So if we do our counting, we have 1, 2, 3, 4, 5, 6. Okay, now there's 2 double bonds. So when there's 2 double bonds, we have to say where each of those double bonds are located. So we would say for this guy, we'd say it's 1, 3, and then it's 6, so it's hexa or hex. And then instead of saying ene, we want to know that there are 2 double bonds. So we say diene. So we call this guy hexadiene. Okay, so it'll be 1, 3 hexadiene. So since di also means 2, right? So for the Greek, you guys know your Greek prefixes? Mono, di, tri, tetra, penta, hexa, deca, sorry, hepta, octa, nona. Yeah, so your carbon prefixes are all the same pretty much, except for these first 4. Okay. So do you guys get that? Do you understand? Yes. Because we count the carbons, 1, 2, 3, 4, 5, 6. What? No, I'm getting there. Trust me. So since the very first double bond is on that first carbon, so that's where we get that 1 from. Since the second double bond is on the 3rd carbon, it starts at the 3rd carbon. It goes from the 3 to the 4th carbon, right? That's where we get the 3 from. Why didn't I go the other way? Because 1 is lower than 6, right? So if I count it from this direction, 1, 2, 3, 4, 5, 6. So then my lowest number here would be 3, where my lowest number here would be 1. So you want to have that lowest number. So that's how you decide which way to count. And which way? The top one, it does matter. So when we count it from both sides, right? But you notice we used the 1 nonene. We didn't use 9 nonene. If we count it from this side first, if we count it this side, that guy would be on the 8th carbon. We would say 8 nonene, right? We didn't use 8 nonene because that would be incorrect. Because 8 is greater than 1. You always want to have a functional group at the lowest number. Okay? Do you guys understand? A little bit. Don't worry about it. You will after we do like another 25 more, right?
So hexadiene is one word. We're not breaking it up. There's no spaces or nothing. That's just a complete one word. That's how it would be written.
However, you will see it written multiple ways because chemistry is kind of generational. So some generations learned it a different way, right? So, for instance, when I did it, we put dashes in between it, right? So we would put hexa, then we put dash, dash, ene, right? So, but I'm a different generation. Today, they just put it all together. Okay. So if you do it either way, it's technically
it's
acceptable.
still right.
Yeah, it would be acceptable. Yes.
Okay.
Okay. So let's see. Let's say we have this guy. Oops. Sorry. Okay, Luis at NDC, you'll do A. B will be Chantel. And then C will be Stephen. Okay, so. Okay, so this is what Luis gave us. Chantel? Okay, so you said no 9. Okay, but you're unsure about no 9. Okay. Let's see. So we have no 9. Okay. So anybody want to help her out with it? So she says the prefix is nona. You guys agree with her? 1, 2. Okay. Hold on, let's do the counting here, huh? So we got 1, we got 2, we got 3, we got 4, we got 5, we got 6, we got 7, we got 8, we got 9, we got 10, we got 11. Okay, so you guys have to remember it has to be at each end of the triple bond. That's carbon. Carbon there, carbon there. Right?
Dr.
So there's 1, 2, 3, 4, 5, 6. Oops, sorry, I missed one. 6, 7, 8, and then let's fix that. 9. It's 12. My bad. We'll help you out. Give me a second. Let's see. So we're at 9, 10, 11, 12. So at each end of the triple bond, that's a carbon, right? So that's 1, 2, and then it's the points 3, 4, 5, 6, 7, 8, 9, and then 10, 11, 12.
I have a quick question.
Yep.
So the triple bond, okay, because I'm trying to see it. Okay, so as a whole, that's 1. And then we're looking at the original carbon, right? Which is 2. Is that
Yep.
how you get it? Okay.
Yep, so that would be, if you looked at this, this is what this is showing. You're seeing C, triple bond, C. Then you have C, single bond
Right.
with its hydrogens. Then you have another C
Which
here.
is 4, right?
Yeah,
1,
that
2,
would be our
3,
fourth
4.
one. Yep.
Okay.
And then another C, so on and so
Yeah.
forth.
Okay.
Okay. Okay, so let's see if we can fix that name up. Okay, but how many double bonds are there? There's 2. Where are they located?
1 and 7, right?
1 and 8. So it'll be 1,
1
and
8.
here's the 8, right? Right here. It starts
Oh
at the
yeah,
8.
that's right. Yeah, okay.
So 1, 8, and you said there's 12, so that would be do, deca, and then di, and then YNE, which is ugly. So in this case, I would put the dash there because an I and a Y next to each other is ugly.
Professor, you can't just drop the Y since I make, drop the I since Y is
No,
I
that would,
anyways?
that could mean something else, particularly in organic chemistry. So you don't want to do that.
Oh, okay. Okay.
Okay, I need you guys to kind of settle down. We had a question. So you count 1, 2, 3. That counts as a triple bond. Okay, so because since there's 3 lines lined up together, that's a triple bond. Yeah, you number it on both ends. That's 1, that's 2. So it's on between carbons. Counting the carbons, the 1 and the 2 represents the carbon. Right? So let me give you a smaller example. Yeah, so that's the first carbon. This is our second carbon. This is our third carbon. This is our fourth carbon. So in other words, what I'm saying is we have 12 carbons, right? I'm going to draw this at the bottom. So it's carbon, triple bonded to another carbon. So that's 1 and 2, right? And then we have a single bond to another carbon. So that's 3. And then we have a single bond to another carbon. That's 4. And then we have a single bond to the next carbon. That's 5. And a single bond to the next carbon. That's 6. And a single bond to the next carbon. That's 7. And a single bond to the next carbon. That's 8. And then there's a triple bond to 9. Yeah, that's right. Oops. Okay. And then we have a single bond to the next carbon. That's 10. Oops, I was going to write 10. This is 11, and I'm running out of room for 12, so I'll put it up here. And then we'd have the hydrogens surrounding it so that it has 4 attachments. So we'd have hydrogen here, a hydrogen here, a hydrogen here. That's right, that's why they're called hydrocarbons, right? Hydrocarbons, hydrogens and carbons. To name, it's for naming the hydrocarbons. So for instance, you guys use gasoline. Okay, if you look on gasoline, it tells you what a gasoline is made of. What does it say on it? Starts with an O. Not oxygen. It doesn't say oxide either. Octane. So octane, if you think about octane, how many carbons does octane have in it? 8. So it's an 8 carbon chain that's all single bonds. Okay. Do you guys, how many of you guys grill? Grill, like barbecue grill, right? You grill. So do you guys use propane? How many carbons does propane have in it? 3. How many of you guys, I shouldn't even ask you this, but I will, I'll ask you. How many of you guys dap, or know what dapping is? You guys don't know what dapping is? Yeah, like dapping, right? So if you dap, right, you buy butane, right? And what do you think butane is? It's a gas, but it's a hydrocarbon that has how many carbons? It has 4. Okay? So okay, so are you guys getting this? You see it? Can you, is it kind of sinking in a little bit? Or you guys want to test out a little bit more before we move on? What about you guys in Kalinga and in Fireball? Oh, Stephen, I'm sorry, I forgot about you. Go ahead, Stephen. So C. What would be C? Do you guys want to help him out with C? Maybe you put it on my window. Nope. Are you there, Stephen? Did Stephen dap out? What was that? Butane? Okay, so we have an answer. We say butane. Do you guys agree? 1, 2, 3, 4, butane. Okay, you guys ready for the next one? Because, you know, this is too easy. You know, we're going to make it a little more challenging. Okay, let's see. You know, obviously it's too easy because you guys are talking a whole hell of a lot there. Let's see. 1, 2, 3, 4, 5. Okay, so for this one, we're gonna have Maria at Fireball. We'll have let's go with Juan. Juan is gonna do B. And let's see. At Kalinga, Ara, you're gonna do C. It gave me 2, 5. Deca, Diene. Was that? I'm doing that right now. I'm typing it. This is what Juan gave us. Is that correct, Juan? Did I write it down right? Okay. So let's do the counting. Well, we're gonna just relax. We're gonna look at it together. Okay, so if we look at this, this is the first carbon, this is the second carbon, this is the third carbon, this is the fourth carbon, this is the fifth carbon, this is the sixth carbon, this is the seventh carbon, this is the eighth carbon, this is the ninth carbon, and this is the 10th carbon. The triple bond starts at the second carbon and it starts at the 5 carbon. There are 2 triple bonds. So that's why we put the di. And it's a triple bond. So that's why we put Y and E. D, we'll get there. You don't have to, but it just looks prettier. I'm O. Okay, so Arya has, for C, 1 octane. Maria Figueroa, are you there? Okay, so for A, what do you guys, where am I going to start counting from? Left or right? One, 2, 3, 4, 5, 6, 7, 8. That's right, 2 and 4. So it'll be 2 and 4. So it's 2, 4, octa, okay. How are you guys doing so far? Pretty good? Okay. So on D, we're going to start talking about branching structures, right? So when we start with the carbons, we want to find the longest possible carbon chain. That's going to be our primary chain. That's going to be like the carbon's last name, okay? So that goes at the very, very end of the name. So what we'll do is we'll count to see if we can find the longest carbon chain. So if we start here, that's 1, that's 2, that's 3, that's 4, that's 5, that's 6. If I start here, that'll be 1, 2, 3, 4, 5, 6. If I start here and go the other way, that's 1, 2, 3. So 6 is going to be my longest possible carbon chain, right? Where all of the carbons are connected together. 1 carbon chain. 6 would be the longest. So I can start it from right here, okay? So I said you want to find the longest carbon chain. In this case, 6 is going to be our longest carbon chain that we can have. That where all of the carbons are connected together on 1 single chain. Okay? So 6, what would be that root, that prefix for hexa? Okay? And it's a single, is it a single bond or is it a double bond? Single. So we'll say hexane, right? Okay. Wait, hold on. Just relax. Just relax. Okay, so we have a branch coming off, a branch with only 1 carbon attached to it. So it has 1 carbon attached to it. If it has 1 carbon attached to it, what is that prefix that we will use for 1 carbon? That would be meta, right? So in this case, we'll have to say, wait, hold on, just relax, just relax. Okay, so we will say where it's coming off of, which carbon it's coming off of. It's coming off the 2nd carbon. So we're gonna say 2 meth all YL hexane. Okay, so it would be 2, sorry, I forgot my dash. It'll be 2-methyl hexane. Because you have 1 carbon coming off of here. To tell me that it's a branch. So the YL means that it's a branch coming off the 2nd carbon. Yeah, so if it's a branch coming off the carbon, you want to add the YL, right? So if it's not on the main chain and it's a branch coming off the carbon, you want to add YL. Okay? Okay, so here, let's take a look at E. The first thing that we want to do is to do what? Find the longest carbon chain, right? So let's say if I started here, 1, 2, 3, 4, 5. That's not, there's something longer? Okay, so let's go here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I go here, that'll be 1, 2, 3, 4, 5, 6, 7, 8. So what is the longest? Okay, so the orange numbers, right? That would be the longest carbon chain. So we're going to use that as our primary chain. Now, the next thing that we want to do is try to find the lowest, make sure it's the lowest number, right? To the first functional group. In this case, the functional group is just this branch structure right here. Let me circle that in brick. Okay, so that would be a functional group with how many carbons? 1 carbon. Okay, so since there's only 1 carbon, what are we going to call it? Methyl. Okay, we have to tell us where that methyl group is at. That's the number that we put in front of it. Where is it located at? Which carbon is it coming off of? It's coming off the fourth carbon. So we go for methyl. And then we do our primary chain. Oops. Oops. Oh, crap. So 4 methyl decane. Piece of cake. Okay. So shall we make it a little bit harder? Oops. Oh, you weren't done? I'm sorry. I'll go back. Hold on. Yes. Okay, guys, I need you guys to lower it a little bit so I can hear what she's saying. It is a bond, but it's a branching bond, right? It's branching off that main carbon. So it's considered a branch, like a branch off a tree. So you have the main tree and then you have branches, right? It's the same thing. Here's your main tree, the numbers that are counted, and then this is your branch. That would be your very first branch. It has one branch. That's right. What's that? Yeah, because there's only one carbon here. That's one carbon. If it was two carbon, yeah, if there were two carbons, then we would call it ethyl. If there were three carbons, we would call it propyl. Yes, that's what I was going to do next. Then you have to account for all of the different branches that there are. I'll give you an example of that here too. It's not clicking. Okay, so you want to find the longest possible carbon chain, right? So if we go through and find the longest possible carbon chain, I don't know if you guys can see this. Hold on. 1, 2, 3, 4, right? So this is the fourth branch. When we go off the fourth branch, that's one carbon off that branch, okay? So, but then there's 5, 6, 7, 8, 9, 10. Okay, so that gives me the last part. It gives me the last part of it. So we know it's a decane, right? So let me type that in again. Because we know that it's a 10 carbon chain. Now it's coming off the fourth carbon. There's only one carbon coming off that fourth carbon. That right there represents that one carbon. So if it's a one carbon, what do we call one carbon? Methyl. And since it's a branch, we put the YL at the end. So we call it methyl. It still would have been methyl, but the number where it's located at, where it's coming off at, we put 4-methyl here because it's coming off the fourth carbon. You're telling me where it's coming off of. So I have a methyl group coming off of the fourth carbon. The branch is coming off the main chain, it's a YL. That's right. That's right. Well, if there were two carbons, it would be ethyl, not if there were two branches. I'll show you the difference between the two. Okay. Yeah, if there's branches, you add the YL. Yeah. Okay. Can I move forward? Okay, let's see. What was that? That's right. Okay, so let's say we have this guy. Okay, so first thing that we want to do is to do what? Find the longest carbon chain. Okay, so we have 1, 2, 3, 4, 5. Excuse me? I could, if I went 1, 2, 3, that would be a really short chain. Does that make sense for me to do that? I don't have to start from the other side. I can start from this side. Because I chose I wanted to go that way. I can start from either side, right? No, you just want to find the longest chain and you want to make sure you have the lowest numbers, right? So where am I going to come into the first contact with a branch? If I start from this side or if I start from that side? Starting from the left, right? Okay, so it makes sense to start where stuff is at, right? So you have stuff on that side to give them the lowest number, because if I started from the other side, these guys would be really high numbers. We want them to have the lowest possible number. Okay, so just think about it. You always want to try low numbers. Low energy, low numbers. Don't want to do too much work. Okay, so if I went 5, this would be 6, that would be 7, that would be 8, that would be 9, that would be 10. Right? So that would be this way. If I went this way, that would be 6, this would be 7, this would be 8, this would be 9, this would be 10, this would be 11, this would be 12. So this is much longer than this guy. Would you agree? Okay, so let's go ahead and number that. That's 6, 7, 8, 9, 10, 11, 12. Okay, are there any double bonds? Are there any triple bonds? No. So I know the very end of the name of this compound is going to be dodecane. Okay, so now we're going to be putting these guys in alphabetical order, right? So because we know that off of the second carbon, what is that going to be coming off that second carbon? Is it going to be a hydrogen? It's one carbon. One carbon is called methyl. So I'm just going to type methyl here to remind me that that's a methyl group. Oops. Okay, so on the 5th carbon, what's coming off the 5th carbon? How many carbons are coming off the 5th carbon? So that's 1, 2, 3. Propyl. Okay, so I'm going to type propyl there. And then off the 6th carbon, 1, 2, 3, 4. Butyl. Okay, so when I go to do this, I'm going to do it in alphabetical order. Oh, I forgot. Oh, I did forget about the branch coming out for 3. Thank you. It's a good eye. What is it? Okay, so that means I have 2 methyl groups. So how would I make it so that I have 2 methyl groups? What was it? Come on, you guys. I know you're right there. How do I make it so there's 2? Di. That's right. So then what I would do, again, it would be alphabetical order based upon what we have there. So we put butyl first, bu. And so where's the butyl located at? So it'd be 6 butyl. Then is M lower than P in the alphabet? Okay, so then we put, but there's 2 of them, right? So that's, yeah, alphabetical order. 2, 3, and it's dimethyl. And then 5 propyl. Five propyl dodecane. Okay. Did you guys get that? Simple, not too hard. Okay, so let's add a couple more. Don't erase it. Okay. Don't worry, we'll get to that. Just relax. She's just jumping to the end of the chapter already. She's like, okay, so we have this structure here. First thing I'm going to do is to do what? Longest carbon chain. Oops. 1, 2, 3, 4, 5, 6, 7. So if I go this way, that'll be 8, 9, 10. If I go this way, that'll be 8, 9, 10, 11. 8, 9, 10, 11. Okay. Okay, so what would be my, okay. On Undeka die ENE. Okay, so you're telling me, okay, where are those double bonds at? Because you're telling me I have two double bonds, right? Okay, so I go 2, 4. Okay. Okay, so what do I have coming off the third? Number 3. You said it's going to be what? Propyl? Are you sure? Because I see you don't. Ethyl, that's right, ethyl. Okay, so we're going to have ethyl here. So that guy's ethyl. Okay, and this guy, what about 6? Methyl, okay. So the next one, that's a 4 right there. That's a 4. That's, oh, 7, that's 1, that's 2, that's 3. Propyl. Okay, number 8. Methyl. Okay, so now our name is going to be so 3. That is correct. This is organic chemistry. So this is 3-ethyl. Okay, so you said 6, 8 dimethyl. Is it 4 propyl? Isn't that a 7? Okay. 7. Okay, piece of cake. Okay, so I think this is a good stopping point. What do you guys think? Okay. Okay, so then I will see you guys on Monday. I got a couple of messages about the discussions are not visible to everyone. So when you guys do your discussions, if you do them within your group, they're going to be showing up only within your group. Okay, so you have to go to your group and then click, it'll give you to your group page. You hit click discussions and your discussions will show up there. Okay. Your exam is going to be opening up officially tonight. It'll be open up until Sunday night at 11:59. Yeah, no, I had to get something fixed. So that's why I'm extending it to Sunday. What's that? So it's not due Friday, it's extended till Sunday. Okay. $1 million to give to me. Yes, yeah. Your exam, yes. Okay. Are there any questions at Kalinga and Fireball?
No.
I'm trying to hear their questions. Oh, that was a really good question, actually. But too bad we can't hear it over here. So they don't need to know. Don't worry about it. But I'll give you guys the answer here. So are you ready? But you guys weren't listening. It doesn't matter, right? Oh, you're listening now. Now it's important. Okay, so there's a question about the uploads. So you guys have short answers that need to be uploaded. So you have questions that are going to need to be uploaded. You have a part that says exam 1 upload. You want to take a picture of your exam. You want to save it as either a PDF or a JPEG. And then you want to upload your scratch work from your exam. Okay, and then also those answers. Make sure you have those answers boxed clearly so that I can understand where they are. Show your work because you get partial credit. If you don't show your work, there's no partial credit, right? It's either right or wrong. So it's always good to show partial work. Let me know that you at least are thinking right. And then it also lets me know where I need to work on, what I need to work on with you, I should say. Okay. Are there any, yes, there's a question. You can get partial credit if you got the answer wrong. Yes. Yeah. Except, like, the multiple guess questions, it's multiple guess. Yeah. It's either right or wrong. Yeah.